afternoon. Welcome to lecture 40, classification and regression tree, CART in abbreviated form. This is under module 8, predictive safety and risk analytics, part 1. In last lecture, you have seen logistics regression, and that we have used in terms of classification as well as that can be used in terms of regression. Similarly, CART can be used from the regression tree point of view, from classification tree point of view. We will discuss CART in terms of classification tree. So, what are the things that you will be learning in this lecture today? We will introduce what is CART, and then we will tell you how the CART will be developed, what are the different steps. Each of the steps will be explained, and in the process you will see that CART uses impurity measures for its development and what are the model overfitting issues. So, CART is a decision tree based classification model. It uses binary recursive partitioning algorithm. So, we will discuss all those things one after another. So, one is it is a decision tree model, second one is its algorithm is binary recursive partitioning algorithm. So, we will see in next slide that actually the tree is built by splitting a node into two different nodes, and we continue this process so long certain predetermined homogeneity in the leaf nodes are achieved. Okay. So, the process begin at the root node. Primarily it is basically the class variable which is considered in the root node, and from the learning point of view it is the similar, it is another machine learning technique. What happened, we will develop the CART algorithm, and the algorithm learn based on using the training data, and once algorithm is learned perfectly based on the training, then the model can be used or verified using the text data, and then when new data will come, so you can use the new data from the classification point of view. So, that same structure it follows here. So, it is a supervised algorithm because it has output or class variable also, which is y, as well as there are set of input variable or predicted variable which are known as x. By this time you understand this x and y. So, now I will discuss little bit that what are the different nodes. I already told you earlier that it basically start with root node, and then gradually at every node it splits into two branches. That is why binary partitioning, and it will continue the branching or splitting so long some kind of termination condition is not achieved. The termination condition we will discuss little later. So, considering this binary splitting starting from the root node, there are three kinds of nodes you will be seeing in a CART or classification tree. So, what are those three types of nodes? One is the root node, which is the starting point. Usually this is starts with the class variable. Then there will be internal node and there will be leaf node. The difference or the definition of root node, internal node and leaf node is like this. When you say root node, you will find out that in the root node there will be no incoming edges, only there will be outgoing edges. For example, this is your root node, so outgoing edge is this one is outgoing edge, there is no incoming edge. What is your internal node? Internal node on the other hand will be having that input node as well as output nodes. So, other way I can say, here you see there is incoming edge and here outgoing edge. What does it mean? That means the internal node will be further split. What is leaf node? The leaf node just opposite to root node. In the leaf node there is incoming edge, but there is no outgoing edges. So, you will understand cart in terms of nodes and basically that split. The nodes starting from root node, you have to reach to leaf nodes, and in between the branching will be binary, in the sense two branches against each node, so long the leaf nodes are not achieved. So, with this graphical information, let us go to the next slide, where we are discussing in detail that what is the conceptual model of cart, or I can say what is the process model of cart. You have already seen in the last slide this particular diagram. This tree you have seen. So, how we will develop this kind of tree? What are the inputs, what are the outputs, and what algorithm we will use? So, that basically comes under process model. That means what in the algorithm what we do, that is the different steps you have to do in sequence, some may be in parallel. So, that is why it is termed as, this algorithm also can be thought of a process. Now, let me tell you, in order to do cart, what are the inputs? So, you have to have predicted variable x. This you have seen in logistic regression also. There is predicted variable 1 or more. So, if there is one predicted variable, it is 1x. If there are multiple predicted variables, then p number of x. And second one is class variable y. So, class variable can be labeled continuous, so or categorical, depending on this. Actually, the output also will be either categorical and continuous, but for this particular lecture we are considering classification. So, y is our categorical responses. Okay. Then what actually will be your output? I can tell my biggest output is the cart model, that is basically the decision tree. The tree model, that will be the output, and that output, that model will be used for what purpose? For labeling new observation, or when a new observation will come, using this cart I will be able to tell that what are the it basically belongs to which class. That also you can yes, that kind of rules can be generated, no problem. Another one is basically, that is another important inputs output will be basically, you have seen that when you are splitting the data into different parts, basically see, suppose root node I have 100 observation. When you split into two parts, maybe here you get 30 observation, here you get 70 observation. Further splitting, here you may get 30 and here you may get 40. And then you are saying leaf node, basically the concept is, in the leaf node the observations are more homogeneous. Here the homogeneity of the basically data is less compared to the leaf node. So, that kind of splitting when you are doing, So in the process, at each of the split, what is required basically, you require the information of x. Here maybe you are using information x1, here maybe you are using information x2. So as a result, what happened from the cart, another important output will be which predictor variable is contributing the maximum. So I can use cart is 1, and obviously this accuracy will be under the model itself. 2 is leveling of new observations. Third one is basically you want to know the significance of the predictors. Significance of the predictors. What are the predictors? Predictors are the x variable. Means suppose I have 10 x predictor variable. I want to know which are the important predictors. So that also you can find out. In addition, you can generate also several rules. That is basically, as I said, that the rule based prediction also you can develop here with the help of cart. Fine. So you know input, you know output. Now how you will develop the cart? This development, there are certain steps. Okay, so first step is basically tree growing. Tree growing, actually you see, you start with the root node, then you continuously do branching with the help of predictors, and finally there will be many internal nodes, and at the end you will find out leaf nodes which are not further be split, because even if you split, you will not get any additional benefit or gain. So that is the first thing. Second one is basically how long you will continue, that is called when to stop the developing the tree. So when the growth will be stopped. One is when you find out that all the observations have been labeled into class. Ultimately, if I start with suppose 3 class or 2, let 3 class, let the root node, the class variable y is risk, low, medium and high. Now what happened, once you split with the help of suppose x1 may be certain kind of hazards. So based on the hazard, suppose there are several hazards, but you are considering one kind of hazards at the left and all other you are combining together, and here you are finding out that all the observed values are of low. So that means you don't require to split it further, because all the observation 30 observations, that the risk value, the class value is low. But here what happened, it may be so that it is medium, low and high, all may be there. So when such heterogeneity is there, so you further split. Now another variable or the same variable may come, you split. Suppose in leaf node we are saying here let all are medium. Then here may be high and low is there. Let some low and some high, it may be there. So that is the issue. That means you are ultimately partitioning the total data set into smaller part and continuing the partitioning, so that so long you are not getting the homogeneity, required homogeneity, or you are finding out there is no more improvement possible. So the best way is, if you find out leaf node, that is the important part of it. And another one, as I told you, that the same I already have, all observation belong to the same class. All observation have been labeled into classes, and all observation belong to the same class. I think in the leaf node particularly, if the homogeneity is concerned, if one class of data is there, that is the 100% similarity. But otherwise what will happen, the similarity will not be 100%, but then you know that okay, certain low and certain high or certain medium, some value, some kind of leveling is there, but at the same time what we actually you are finding out that if you further split into another two branches, maybe the improvement is not, means homogeneity or similarity is not improved. Then third one is basically that prediction point of view, predicting the class probability, predicting the class or probability of a class. So when it say prediction, that means something new comes and fit to the tree, and then the learning model you will find out, because their class variable is not there, only the x variable will be there and you can use it. So knowing the x, you can find out, predict the y. So that sense you have to do. So I hope that you got the idea that how the cart is developed, what is the process model, and what are the three steps. The major steps are basically going, that is, and the stopping, and obviously in between you will be using certain measures for tree growth. Those things we will discuss. Now you see, I will start the first one, that how tree grows. One is find each predictor based split. How many predictors are there? Suppose you have p number of predictors. So how many split per predictor can be possible, and then in under each split you find out what is the improvement. Improvement means, as I told you, I have the total data set, I am partitioning it something like this. If I say this is my total data, if I partition like this, so you are creating, this is one set, this is another set. So this partitioning, when you are doing this partitioning, now which predictor variable you are using? The predictor variable, if there are more predictor variable, you have to find out the split of using each of the predictor variable. So first is find each predictor based split. I will explain little later what does it mean. If I say that risk is the issue, and risk can be, suppose for the timing we will consider it can be low and high. Let there are many workplaces you are considering low and high risk place, low risk place. Now it low or high, it will depend on what kind of hazards present. So I can say this hazard is one predictor variable. Now this hazard can be having many categories. Suppose for the sake of simplicity, let hazard has three categories. Okay, hazard is basically hazard 1, hazard 2 and hazard 3. So how many split possible? Binary split. You can find out that 3 binary split possible, because you may consider hazard 1 vis-a-vis hazard 2 and hazard 3, or hazard 2 vis-a-vis hazard 1 and hazard 3, or hazard 3 vis-a-vis hazard 1 and hazard 2 together. So that is what we are it is saying that. So that means there could be 3 split for this predictor variable. Find out which one is the best. How do you find out? You find out this using certain measures that known as impurity measure, that I will come or I will discuss later. So similarly, you have many more predictor variables, not only hazard. So there could be another predictor variable for the workplace point of view. Suppose if I say some workplace is process oriented, some workplace may be process mean technology, process or technology oriented, and someone may be labor oriented. So it may so happen that the risk level will be different for this. So that means another variable, predictor variable. So here how many split possible? One split possible. Process, or I can say manual or mechanized, let it be like this. So here you find out, if you split, what is the improvement. If there is another variable, for example, I consider operator point of view. So, operators may be the who is actually operating the process, say one may be experienced one, another may be inexperienced one, or it may be highly experienced, less inexperienced, medium level experience. So, then again there are 3 splits possible. So, in this manner for each predictor you have to find out how many split possible and which split is giving you the maximum benefit. Then the second one is basically that which split you will choose. You will choose that split which is giving you the best improvement. So, that means you may choose hazard or the process workplace type or the operators that the level. So, which one you choose, one of them will come at the first level, first node. Then after this first node, that first split, these two are created. Then is it a leaf node? Is it a leaf node? You have the criteria I have already said. If it is homogeneous as per requirement, fine, leaf node. Is it a leaf node? It may or may not be. If it is not leaf node, that means this can be further split. Got my point? So, you can further split it. Suppose this is the split, or for this one you can further split this manner. So, again this one is branched, this one is another branching. Now, what is how do the splitting, which predictor variable you take? Again you have to go by the same way, find each predictor best split, select the best split nodes, best split out of all, and then split it. In this manner you continue. Okay, so that means that is what basically find the node and then split the node using the best split, and if stopping rules are not satisfied, stopping rules are also given to you. Okay. So, that is why actually you see that we start with the parent node and then we finally find out that there will be intermediate child nodes, and finally at the lower level the child nodes which cannot be split further. These are termed like this: root node, internal node and leaf nodes. Okay. So, I hope that you understand now what are how the tree is growing. But what I have not said so far, that how the what measures we are taking in the growing process, that I have not said. So, the example I have given you: hazard, then the workplace type, then operator experience or non-experience. Same thing we are basically saying here. The predictor variables could be binary in nature, that means 2 categories, could be more than 2 categories. When they are more than 2 categories, that could be nominal, means the categories are only for identification point of view, or that can be ordinal. Ordinal means there is the order, low, medium, high kind of things, or it can be continuous also. When you have the continuous attributes, you have to make it categorical, something like this. Suppose percentage inspection is a predictor variable. So, in that case what will happen, if I want to split it, you have to see that let complete incomplete inspection and complete inspection. So, let the first one, it is incomplete, that is both are complete, that basically incomplete, as it is less than 90%, may be complete. I think it is better if we write percentage inspection less than 90, greater than 90, that is okay. Okay. So, in this manner you can find out, or if you think no, percentage inspection less than 50, 50 to 75 and greater than 75, that means 3 split possible. So, in this manner, that means for every attributes the split conditions are satisfied. Okay. Please, conditions are defined. Now come to the another important measure consideration, which is said that you are saying selecting the best split, but on what basis? The basis here is impurity. If, as I told you, if I have this total data which is impure, if I split into two halves, definitely impurity here and impurity here will be less than the total impurity. And if that is satisfactory, then only I will split. Now when you are here in the first split, again you will go split further if the impurity in this split and the impurity here and here is lower than the overall impurity. So in this manner, that's why the impurity you have to compute. The impurity measures generally used are entropy measures, Gini measure and misclassification error. We will not go by that how these measures are basically developed. Rather, my interest is to tell you what are those measures, how to compute and how to use it for splitting purpose. So first is entropy measure. In the entropy, this is the formula. You must write down the formula, which is minus I equal to 0 to c minus 1 pi given t log 2 pi given t, where pi given t that denotes the fraction of records belonging to class I at the given node t. As I think I just deleted this one. First one is the root node. So if you split it, that means basically what we are saying, that fraction of records belong, how many classes are there? Let there are two classes. So let this is 60% and this is 40%. Then if suppose this is, let us start that y is high and low. So suppose low 60%, high 40%. Then what is the impurity here? You can use there are how many class? Two class. So I equal to 1 to 2. Then pi given t. So what is pi given t? Fraction means this is 0.4 and this one is 0.6 and log 0.4 and 0.6 two base. You compute, you will get it. You can use other measures, the Gini measures, like this one minus I equal to 0 to c minus 1 pi given t. Here we are using 0 to c minus 1. You can also use 1 to c, because there are c class. C is the number of class. Or misclassification rate or misclassification error using this formula. See, the formula used for impurity computation are not complex formula. These are very simple formula. Only you require to find out what is pi given t at every node, what is the proportion of observation on a particular class. Okay. So with this, I hope that I can show you one example here and how the things are calculated. That is what is the issue here. Here we are basically talking about age or age group of the workers. Suppose there are 3-4 groups. I think we have considered 3 age groups: young, middle aged and old. Suppose this age group of the workers in a plant is considered as a predictor variable based on which the decision tree is constructed. This is an example. Just hypothetically, you just think. The target variable is whether the workers suffer from chronic diseases. There are many jobs where if you work for a long period of time, that unless the occupational health issues are taken care of very nicely, then there is a possibility that that occupational diseases may arise to some individuals. Obviously, old people means they are exposed to more years, so there is possibility of having more disease, that probability of having diseases, some kind of things. So okay, but for the example purpose, we are saying that certain chronic disease can be developed and age is an important predictor. Now we have basically studied 76 workers from 3 age groups, and then when we question them that what is of certain disease status, so this is the count. So out of 76, how many having your disease? 55. How many no disease? 21. It is obvious, maybe because now disease means, if I say disease, then any kind of disease, but if you take a particular kind of disease, then the number counts may change, but for example point of view, I hope that this is sufficient. So that means we are basically talking about the disease status. This is my y variable. So class variable. So either no or yes. Count is 21 and 55. Now what is the impurity in this data? You can use all three measures. From the Gini measures, the impurity in the data is 0.40. From the entropy measures, 0.85. From error measures, 0.276. So please understand that these are not that comparable, okay, that means the same thing is different. No, they are different. The values are different because we have used different kind of measures. But they are talking about for the same thing. So okay. So with this, now whether the age is a predictor or not, it is your purpose is this: age is the predictor or not. If age is a predictor of disease, then you can split this one into based on age. Now how to do it? So let us see that how this can be done. So we have 3 age groups. One is, let it be age 1, age 2 and age 3. So I told you that if a predictor variable has 3 different groups or 3 different categories, so for binary splitting point of view, you can go for 3C2 combination. 3C2 combination. 3C2 means 3. So that is given here. So the 3 different split. So we have considered one predictor variable for explanation purpose, so that computation issue you will understand. Now we know that y status, yes or no, fine. Now what is the status with reference to age 1 and both age 2 and age 3 groups? This is the combination. That means if I split based on age of this combination 1 versus 2 and 3, so this is the distribution of the data in terms of class variable y. Similarly, for node 2, if you compare age 2 versus age 1 3, this is the nature, and for other one, that age 3 versus age 1, this is the nature. So fantastic. So I have now another kind of situation, when using the age as a predictor variable, you have split into that 3 different splits. First split, age 1 versus age 2 and age 3. Second split, age 2 versus age 1 and age 3. Third split, age 3 versus age 2, age 1 and age 2. Now here what is the impurity? So once you split this, you have to compute impurity here, compute impurity here, compute impurity here. Find out where the impurity is less. So let us see how we are doing this. You are using the same formula. That 3 formula we have used. One is your first one. Okay. So I think here we have used the Gini, we are showing Gini index. I think this formula, let me go back. Okay. So sorry, just a minute. You see the Gini index, this formula is this. Formula is 1 minus I equal to 0 to C minus 1 this. So, let me see that which formula we have used. We have used 1 minus, yes, this formula. So, we have used 1 minus I equal to 0 to all class individual class P I by T to the power square that we have used. So, see that we are using basically Gini part here. But please understand, you have to use this probability also, because here in this split for the first one is total number of observation is 9, and whereas in the second 2 and 3 it is 67. So, these measures will be weighted by, for the age 1 9 by 76 total, and for the age 2 and 3 67 by 76. Now, the impurity is this much. If I go for the second split for the age, my impurity is 0.395. If I go for the third split, my impurity is 0.377. Which one is minimum here? The minimum one is the last one, that means age 3 versus age 1 and 2. So, you consider basically this split. You are considering now this is the base split. But please understand, we consider only one variable and it has 3 different split, and base split is this. If there is another variable, so you have to do the same thing for the other variable, and finally you will choose the base split among all the split, and that will be the first thing what you have to do in the splitting point of view. Base split is this. So, this is the way you have to continue. And another one is that once you use the split, that means there will be improvement. What is the improvement? Impurity in the parent node vis-a-vis the child node, if you consider. So, obviously there will be gain in terms of impurity. So, here is the formula which basically used for the finding out the gain. So, I parent minus this, and these are the notations. When we talk about I dot is the impurity measure function described earlier, that means Gini, entropy, misclassification error, all these things. N means total number of records at the parent node, that you know. K is number of attribute values. So, how many j equal to 1 to k, how many in the that you have to consider, and n vj number of records associated with child node vj. So, using this formula you can find out what is the gain in after each split. Immediately above the split, that means the parent node, that gain you calculate impurity, and I stands for impurity. Then when you split this, find out the impurity, the difference actually talks about the gain. Now, you want to choose the condition which gives you the maximum gain. If you want to understand the condition, these are nothing but there are three split condition, this split, this and this. The maximum gain you are getting in root that the third split. So, that is basically based on that condition, means in the sense using the predictor, the condition is and the split, the condition is developed. Okay. So, this is what very important part of CART we have described so far, that how to develop the tree, classification tree. And stopping rules I already discussed. Their strategy 1 is all records belong to the same class, or strategy 2 that all the records have identical attribute values. Okay, let me repeat it again. So we are basically saying y is the class variable and x basically the attribute variables. Now when you are basically splitting just one, suppose this is the big one, split, then again it splits like this. So a situation may be here only y one level is available, but here maybe y different levels are available, but if you consider the attribute values, they are identical. So no more splitting possible there. So this is the thing which I at the beginning I did not mention in the but you please keep in mind this one. Okay. So once these two conditions are raised, you are basically stopping, you are not doing it further. But after that, what will happen? If you want to predict, what you predict? Prediction means given a new observation, you want to know under which class it will fall. So you can tell some kind of point. Prediction means you say, okay, the risk value is low or the severity value is high if the severity is the class variable or risk is the class variable. So that sense, or you may say that probability that severity is low with probability 0.59. So that when you talk about the class as well as its probability, that is basically the distributional one. But if you do not mention any kind of probability, only say okay, it belongs to that class, so that will become point prediction. So point and distribution prediction is important. Obviously distribution prediction is better because you are not only telling that the new observation belongs to which group or which class, but at the same time with a probability of this. Okay. So I hope that you have understood the basics of CART and some more issues like reasons for overfitting. This overfitting and underfitting, these are important issues, and here basically we want to discuss only that what are the reasons of overfitting, and I request all of you, these are listed here. So as overfitting and underfitting require some more understanding, so I request all of you to go through this overfitting concept and consider it as some kind of home task to you. If you do not understand overfitting or underfitting issues further, so you put in the discussion forum, we will answer you there. And intentionally we are keeping this open to all of you to know that how much you are learning or how good you are learning. So that means you can understand. Now if you want to develop CART model, obviously you have to know this process, and the process or the steps are nothing but tree growing, stopping and prediction. And at the same time, please keep in mind, this is the approach here is machine learning kind of approach. That means there will be training data, test data, and your model will be considered useful for prediction or classification here once the model fit in terms of training and test that is satisfied. Okay, particularly you may find out a situation when the training data model fit is very high, but when you are using test data it is very not that high, so then it cannot be considered as a good model. So with the fitting of that training data and test data, if you see the I can say the performance of the fit measures, from there you will understand overfit and underfit issues. Okay, that's clue I have given you. So these are the references, and that's all. Thank you so much.